Ever wondered how to build a Docker container for a Python or Node.js application? Intrigued? Let's delve deeper. Docker is a fantastic open-source technology that allows developers to automate the deployment management of applications within portable containers. Think of these containers as lightweight, standalone, executable packages that encompass everything needed for your application to run. They have the software, libraries, configurations, and variables your application requires. So how do you utilize Docker to create a container for your Python or Node.js application? It's easier than you might think. First, you need to create a Dockerfile, a text document that contains all the commands a user could run on the command line to assemble an image. With a detailed and correctly configured Dockerfile, you can build an image, which then can be used to run your application a container. Imagine a world where setting up the environment for new project, or even switching between projects with different dependencies, becomes as simple as typing a few commands. That's the beauty of Docker. It's a tool designed to make it easier to create, deploy, and run applications by using containers. To begin your journey, the first thing you'll need is a Dockerfile. Think of the Dockerfile as a roadmap, a blueprint, if you will, for Docker. It's a set of instructions that guides Docker. It's like a recipe that makes your favorite dish. Each ingredient and step has its specific role, and so is the case with a Dockerfile. It holds crucial information, basically instructing Docker about several things. For instance, it tells Docker what the base operating system should be. Just as a house needs a solid foundation, Docker needs a base operating system to work on. The Dockerfile tells Docker whether it should operate on Windows, Linux, or any other operating system. Next, it informs Docker about the files that need to be copied over. Imagine moving houses. You'd need a list of items that need to be moved to the new house. The Dockerfile serves that purpose for Docker, telling it which files are essential and need to be copied over. It doesn't stop there. The Dockerfile keeps guiding Docker by providing instructions on what commands should be run. These commands are like workers in a factory. Each worker has a job to do, and together, they make the factory run smoothly. The Dockerfile lays out these jobs, telling Docker what needs doing and in what order. Lastly, it also sheds light on what ports to open. Think of these ports as doors in a house, allowing the right things to get in and out. Without these doors, the house would be inaccessible. Let's draw a picture. For a Python application, your Dockerfile might look something like this. In this chapter, we're diving into the Dockerfile for our Python app. We'll dissect each line for a clearer understanding of their functions. We commence with a line that identifies the base image. Specifically, we're using Python 3.8. The subsequent line establishes the working directory in the container, denoted as /app. The next line is responsible for copying requirements.txt and the current directory into the /app directory of our Docker image. After that, the next command is the run command. This command signals Docker to carry out a command line instruction. In our case, it's executing the installation of Python packages found in requirements.txt. Next is the cmd command. This command sets the defaults for running the container. For our application, it's programmed to operate our Python app. To recap, a standard Dockerfile for a Python application comprises these lines. Each of them is an instruction, constructing our Docker image in a systematic approach. In the next chapter, we'll replicate this process for a Node.js application. In our digital journey, we have come across a myriad of programming languages, each with its unique capabilities and advantages. Today, we delve into the fascinating world of Node.js, a platform built on Chrome's JavaScript runtime. When we talk about Node.js, we're discussing an open-source, cross-platform, back-end JavaScript runtime environment. It executes JavaScript code outside a web browser, allowing developers to create dynamic web pages before they are sent to the user's web browser. Notably, Node.js is renowned for its event-driven architecture, which is capable of asynchronous I/O. Such features are designed to optimize throughput and scalability in web applications with many input-output operations, alongside real-time web applications. So, how does a typical Node.js application appear? Well, it is not vastly different from other applications you may have encountered. However, it has a few unique aspects that set it apart. Firstly, Node.js uses an event-driven, non-blocking I/O model, which makes it lightweight and efficient. This model allows Node.js to handle thousands of concurrent connections with a single server, reducing system memory overhead and improving performance. Secondly, the Node Package Manager, NPM, is an integral part of Node.js. It is a pre-installed package manager that comes with Node.js installations. It helps developers to install, update, and use smaller modules of code in their applications, further enhancing the speed and ease of programming. Ultimately, the core strength of Node.js lies in its use of JavaScript, a language familiar to many, and its robust technology stack. These attributes contribute to making Node.js a popular choice among developers worldwide. So to give a visual representation, a Node.js application Dockerfile could look like this. Alright, having seen the Dockerfile for a Node.js application, let's break it down line by line. The first line states Docker to use the Node.js 14 image from Docker Hub. This is the base image for our Docker image. The next line sets the working directory in the container to this path, then copies over the package.json, which instructs Docker to copy the package, JSON, and packagelock.json from your local directory into the Docker container. Following run npm install tells Docker to run the npm install, installing dependencies defined in the package.json file. Copy asks Docker to copy the rest of your application code into the Docker container. Expose 3000 makes port 3000 from the container available to the host machine. Lastly, cmd, the default command to run when a container starts from this image. That's a typical Dockerfile for a Node.js application. In the next section, we'll show you how to build a Docker image from this Dockerfile. Once you have your Dockerfile in place, you can build your image. A Dockerfile is like the recipe of your dish, and creating an image is like preparing the meal. It's a straightforward process that starts with putting together the right ingredients, or in this case, the correct commands. The Dockerfile is your guide, your recipe card that tells Docker what components need to be assembled and in what they should be combined. The command to build the image is simple enough. It initiates the process, sets the wheels in motion. It's comparable to preheating oven you start baking. Once initiated, Docker springs into action. It diligently follows the instructions outlined in the Dockerfile, much like a seasoned chef would with a tried-and-true recipe. Docker reads it step by step, combining and configuring as it goes. The result is a Docker image, akin to the finished dish in our cooking analogy. It's a tangible product of the instructions you've given Docker. It's a neatly packaged, ready-to-use software solution, complete with all the dependencies and configurations it needs to perform its task. This image isn't just a standalone item though. You can think of it as a read-only template, a blueprint of sorts. It contains all the instructions for creating a container. What is a Docker container, you may ask? It's much like the serving dish for your meal, the platform that allows your software to run. Your Docker image has all the information needed to create and run this container. It's the essence of your software, but in a flexible, portable, and easy-to-use format. Remember, once you have your Dockerfile in place, you can build your image. This process is all about taking your Dockerfile, following the instructions, and translating them into a Docker image. This image then serves as a read-only template with instructions on how to create a Docker container. Once your image is built, you can run it using the command. This takes the Docker image and produces a container. If an image is a class, then a container is an instance of a class, a runtime object. Now, to access the application running inside the Docker container, you'll need to map the port from the container to the host machine. When you run your image, use the option to bind a port from your host to the container. In this command, any traffic that comes into the host machine on port 4000 gets forwarded to port 80 on the Docker container. In summary, the steps to building a Docker container for a Python or Node.js application are: create a Dockerfile, create an image from your Dockerfile, start a container from your image, access your application by mapping the port from the container to the host, Remember, Docker is a powerful tool that simplifies the process of managing project dependencies and environments. It's a vital skill for any developer to have in their toolkit. The more you use it, the more you'll understand its potential and versatility. So, start exploring and happy Dockering.